Hello, we are going to discuss more organic chemical separations. So this type of separations mostly you're gonna see if you're a major student, chemistry major, or maybe masters or higher levels of programs, maybe finals of major chemistry students exams, right? So it would be an open book test. You will be well versed with the techniques and terminology, and even you have all the data books and other things available to you, right? So let's look at how we can do a three component mixture separation, and sometimes it can be called four component, right? But it's actually three component. Okay, so what's the three components we're going to get? We're going to get normally an acid, an organic acid, something like benzoic, and then a organic base, something like chloroaniline, and then a neutral compound, something like naphthalene. So HA acid, B for the base, N for the neutral compound, right? So yeah, so benzoic is a good common one for lab exams, and then chloroanilines, different types of chloroanilines, and then neutral compound. Normally naphthalene we used to give naphthalene. It's carcinogenic, so normally if available it would be a toluene like this is a good better one than naphthalene, right? Naphthalene is the mothball, so we don't use them anymore, right? Ask your grandma, they know about mothballs, right? Okay. So this could be in the 50 milliliter DCM, or I would say DEE, diethyl ether. So D or DCM, and that makes actually four components, right? But we should call it three component mixture. Now, so we have everything cleared. So we're going to do the sort of the flowchart, like I said, a blank one, and you keep two, one blank, one already with the information you need, like the way I'm doing now. And the first one, 3 times of 15 milliliter sodium hydroxide, dilute sodium hydroxide extraction, separate the AQ and OG using the SEP funnel normal methodology. And what happens, the organic layer will have the neutral and the base, organic base, and aqueous will have the acids salt. That means in this case it's actually sodium benzoate, because it's a salt. It's going to stay in the water, right? Now, so we can separately go these two methods. It's similar to the previous methods, but this one has more stuff to do, right? And you should be aware of what you're doing. So follow the procedure. So now what do? We can actually acidify it with the 5 molar, 6 molar HCl. Check the pH just to make sure it's acidified. And then again, you can do 3 times of 15 milliliter D extraction or DCM extraction. And now you separate aqueous and organic. Aqueous, it's a keeper, so keep it for now. And look at the organic, will have the benzoic acid or the weak acid that we had, the organic acid. So we have it now. So now it's in the organic solvent. You do the normal thing what you do, right? So simply purification and melting point, boiling point. If it is a solid melting point, liquid boiling point, if you get it, then you go back and discard the aqueous layer for that one to the proper waste. That's it, right? So we have fulfilled the organic acid separation. So let's look at the other two. Now what's here? The base and the neutral. It's in the organic fraction, which is not reacted, because they don't react with the base itself, right? The sodium hydroxide. Now what do? You're going to make a reaction here, right? This is actually similar to the neutral and base that I discussed previously. So 50 milliliter of we already have it, D, right? Or DCM. So already there. So 3 times 15 milliliter HCl extraction, and then separate aqueous and OG. And OG has the neutral plus the DE, right? And the aqueous has the salt of the base, right? So the salt of the base has to be treated separately to separate. Okay. Yes. With the neutral, with the DE organic solvent, so you do the normal drying with sodium sulfate, then do the filtration, gravity filtration, then evaporation using the rotoap. So that's done. So you have the crude neutral. So the crude neutral you can further distill or pre-crystallize, and that's the purification. And then you test for melting point, boiling point, or even refractor index, whatever provided to identify what's the neutral compound is, right? So voila, that's done. So we have 2 check marks, 1 more to go. So let's look at again. We already have recorded what we are doing in the flowchart, right? With the pencil, just scribble something what you have done, and that's important, right? So you don't mix up the beakers and things like that. So here, so you have the salt of base, organic base. So this has to be actually, yes, basify, because it's a salt, and then 3 times of 15 milliliter DE extraction, and aqueous keep, and then OG. That's the base, organic base, and the D, the organic solvent. Then do the normal drying with the sodium sulfate, filtration, gravity, and the evaporation using the rotoap, right? Or maybe a distillation, depending on what it is. Now again, we have the crude B. So then what do? You do the purification like I mentioned before, right? So again, check MP, BP, or refractor index, what is appropriate, identify, then you throw the, discard the aqueous. Now you have all 3 done. So this one is actually unknown. You cannot do a previous pH test and figure out what procedure to go. You are kind of going blindly the procedure, right? So that's about the 3 components. So you can say, oh, it's a 4 component mixture, right? Okay, now we're going to do the last one, the 5 component mixture. This has been even like publications in chemical education and so on. So these are really really interesting ones to do for master's programs. And you know, if you're TA preparing for your prof some work, new prof, then probably this is fantastic to do, right? Okay, so what do we have? Neutral, base, organic acid, and it's organic acids are normally weak acids. Now we have plus a weaker acid than the one you already have. So we have already 4 components, and we're gonna add another neutral solvent, something like cyclohexane. Something has a higher boiling point. So that's how you makes the mixture. If it is a exam or something like that, so you want to really surprise your students, and you want to really find out who are the best students versus who are the B plus B B grade students, right? Okay, so what do? Extract with 3 times of 15 milliliter sodium bicarbonate saturated. So that will only react with the weaker acid and separate the OG. And this salt of the weaker acid, so one example is phenol. There are other ones you can find. And the phenol is a little bit dangerous, but you know, at this time, that this type of exam or this type of work, people know what they're doing, right? So acidify, pH check, and once you acidify, you have the phenol itself, 3 times of 15 milliliter D extraction. And yeah, then you separate the AQ and take the OG, keep the aqueous, and take the OG, and then you do the normal what you do. So this one is basically weaker acid, which is in this case phenol, and you have it, and then you're gonna do further purification and identification, right? So So that would be a distillation, recrystallization, something like that, and then check the data sheets. And we look at the organic side, which is now you have neutral, the organic base, and the organic acid again. So this is basically the three components mixture we discussed today. So it's almost the same thing. So, but just understand there could be a extra 30 milliliters, something like that, DCM mostly, and that's part of your organic solvent too, right? So, and that will be easily evaporated later on. Okay, so what do we do? So the three component mixture idea, 3 times of 15 milliliter, sodium hydroxide extraction, dilute sodium hydroxide extraction, and then we separate the aqueous and organic layer by the SEP funnel, using the SEP funnel, and you have the acid salt like benzoate, sodium benzoate, and you have the neutral plus the organic base here, right? So now you can you have the salt. You need to have 3 times 15 milliliter extraction. Actually here, because it's the salt, we need to acidify first, right? We need to convert that into the organic acid first. So acidify, and then check the pH, 3 times 15 milliliter extraction, separate the aqueous, keep the aqueous, get the OG, and then purify, identify melting point, boiling point, refractor index, right? Okay, we look at the other one. So now this is a neutral and base. Just follow the first video, and it's a standard method you're going to use for neutral and bases, right? Okay, so that's how a 5 component mixture separation. These are about 2-3 hour heavy, well organized work with proper equipment provided, right? So that's how it should be done. All right, so any questions, let me know. Thank you.